Hello, ladies and gentlemen. Today we're going to be talking about transformations. Transformations are really something I think you can understand intuitively, but we're going to take that intuitive understanding and we're going to expand upon it, make it very specific and precise, because those are probably our two most favorite words in math, specific and precise. So let's dive in, shall we? By the end of this video, you want to be able to tell the person next to you, or your dog, or your cat, or your parakeet, your turtle, your hamster, your chinchilla, whatever is next to you. You want to be able to tell them two things. What transformations are in general, just what is a transformation in math? And then secondly, what are the four main types of transformations? How can you tell them apart from one another? If you can do those things, you're ready to move on to the next video. So let's try it out. What are transformations? Well, maybe you've seen those movies, or maybe you've seen the cartoon show or read the comic books of the Transformers. They're these space robots that come to Earth, but they're robots, but they can change into cars and then change from cars back into robots and change into other cars and so on and so forth. They are transforming, meaning they are changing their shape, their substance. They're changing themselves into something else. Well, in math, it's very similar to that. In math, a transformation is simply when you take a shape and you change it or modify it in some way. You can modify its form. You can modify its size, make it bigger or smaller. You can modify its position, move it left, right, up, down, and you can change its rotation. When you do these things, you are changing the shape. You are transforming the shape, figure, point, line, etc. So what is a transformation? In general, a transformation is just when you take a shape and you modify it in some way mathematically. Okay. So then, if that's all a transformation is, what are the four main types of transformations? We're going to start off with, I think, the easiest one to do. It's called a translation. A translation is simply when you take a shape and you move it. That's it. This is a transformation. This is a transformation, and specifically, this is a translation. You're changing the shape's position. Notice that the shape is staying perfectly the same. It's not changing anything about it, right? It's still, when it moves, let's move it. Here, we'll move it. We'll draw the old one there. Yeah. Maybe something like this. Notice that it's not changing anything about the shape itself. It's still the same shape. Same angles, same side lengths, same orientation, same shape. It's just changing its position on the graph. That's a translation. Think of it like translations in words. Like the word hello can be translated into hola or aloha or konnichiwa. It can be changed into these different words in different languages, but they all mean the same thing. It's the same meaning, just said in a different place. It's the same shape, it's just seen in a different place. That's why it's called a translation. It's not changing the shape, it's just changing its position. If you want an easy way to do this, just take your fingers on the shape and slide it. A translation is when you slide the shape somewhere else. Okay. What about a reflection? Well, if you've ever seen yourself in a mirror or seen yourself in a puddle of water or some sort of, still liquid, you've seen a reflection. A reflection is simply when you change the side of the graph that a shape is on, and you flip its figure. Because you could make the argument, Mr. Grab, I can just slide it to the other side of the graph. Isn't that a reflection? Not quite. Because notice, there's something about reflections that look very different than translations. Right now, I'm reflecting this over the y-axis. It's going from one side of the y-axis to the other side, the right side to the left side, the right side to the left side. See that? And now I'm flipping it over the x-axis, going from one side of the x-axis to the other side of the x-axis, above it, below it, above it, below it. Notice when I put the two of them together, though, it's not as if I took my two fingers and slid the shape down. If I had taken my two fingers and slid the shape down, I would expect it to look something along these lines, right? It would look something like this. But notice it's kind of changed its rotation. That's because when we have a reflection, what we're doing is we're actually flipping it over. And you've seen this. If you've looked at any words in a mirror, you notice they go backwards, or shapes, they go on the opposite side of your shirt when you're looking at it in a mirror. That's what's happening with a reflection. You're getting a mirror image. You're getting the reversed image on the other side of the axis. That's a reflection. A perfectly reversed image of itself on the other side of an axis, the other side of the axes. That's a reflection. What's a rotation? Well, perhaps I really hope you've heard the word rotate before, but if you haven't, rotate is simply when you spin something, right? You spin something, like you're rotating a top, or you're rotating your wrist, or you're rotating a wrench. You're rotating means you're spinning it around in a circle. Well, in math, it's the same thing, but it's going to look a little different. It's not going to spin it around right here. We're going to spin it around a certain point. We're going to spin it around this point here. So imagine if everything was on a circle around this point. When I rotate it, that means I'm going to take it and move the shape in a rotating manner around this point, like that. And you might say, well, Mr. Grab, doesn't that look an awful lot like a reflection? To which I would say, I'm so glad you pointed that out. They do look very similar. And this is something that trips me up. Very, very similar looking transformation is rotations and reflections. Because it is moving, but it's not sliding. It's changing its shape. But notice that with a rotation, while it may change to be on the other side of the axis, it's not a reversed image, not a perfectly reversed image. If we were trying to reverse, let's say this is the rotation, right? It's going over there. If this was a reflection, we would expect our shape to look something like this, right? Let me do that a little bit better. Something like this. A perfect mirror image of itself flipped on the other side of the axis. But we don't have that. Instead, we have something that looks like it's just been moved and then spun around, grabbed and twisted. Notice that on the right-hand side here, this long flat edge is pointing away. And now this long flat edge is pointing down. It's changing its rotation. It's not flipping as a mirror image. We're going to go into more detail on this later. This is a really tricky one for me specifically. But if you're just being really careful about noticing at this point rotations and reflections and trying to figure out which one looks like a mirror image and which one just looks like it's been rotated or turned, that's going to help you go a long way. But a rotation, in short, is just when we're spinning a shape in relation to a certain point, typically the origin, the center point of the graph. Okay, last kind of transformation we're going to talk about today is called a dilation. A dilation, perhaps you've heard of dilated pupils, right? They shine lights in your eyes when they're checking to see if you have a concussion, to see if your pupils are dilating equally or dilating at all. Dilating is when you change the size of a shape. This is probably the easiest one to spot, so I'm not too worried about you knowing it. It's just the word that's a little weird. Dilation. You're changing it to become bigger or smaller. Notice that the shape itself is not changing its rotation. It's not flipping. It's not turning. It's just getting bigger or smaller. Okay? That is a dilation. Sweet. So let's test it out. Let's try your hand at these. I'm going to show you something. I want you to tell me what kind of transformation is it. Is it a translation, dilation, rotation, or reflection? Which one is this? I hope you're thinking of a translation, because you'd be right. Imagine you're putting your little finger on there and you're just sliding the shape over. There you go. Translation. Next one. This one's a little tricky, but let's just break it down. If it was a translation, I would expect to grab the shape and move it over, right? And it would still kind of look something like this. It doesn't have that shape, so it's not a translation. If it were a dilation, it would be getting bigger and staying in this general area. It's not getting bigger or smaller, so it's not a dilation. And if it was a reflection, it'd be like turning a page, grabbing this and flipping it over. It would look something like this, right? But it doesn't look like that. So instead, the only thing left is a rotation, and that's exactly what it's doing. It is rotating around this axis, or rotating around this point, I mean. Cool. All right, that's a rotation. Let's do another one. What kind of transformation is this? Well, if this was a translation, once again, I would want to preserve the shape exactly. And I would imagine it would look something like this, right? It would still have to have these angles pointing out and kind of going over, creating this kind of, I guess, shelf overhang on the right-hand side. But it doesn't have that, so it's not a translation. It's not just being slid over there. It's not really rotating because it's not changing its what do you call it? Its orientation around a point, but rather it looks like it's a reflection. It's a mirror image of itself. So this would be a reflection. All right, last one. Here it is. Arguably really easy to spot. It's just changing its size. Immediately we know dilation. Don't even have to think about this one. It's changing its size. It's the only one that really changes size. So that one's the easiest to remember. Okay, folks, that's going to be it for this video here. Hopefully you have at least a mildly okay grasp on transformations. What are they and what are the four main types? Try and say them on your own to a dog or a cat or a pet or a friend. And if you can, sweet, move on to the next episode. Otherwise, maybe you want to rewatch it and just be safe to have these. Anyways, I'll see you in the next video where we really take a deep dive on translations. Okay, see you there.